Last night, the solar system held its breath. At exactly 4 a.m., Universal Time, October 3rd, the interstellar object known as 3I Atlas swept past Mars, closer than any foreign traveler has ever come to a planet in our system. For months, NASA's orbiters had waited for this moment, their cameras pointed, their instruments charged. It was supposed to be routine, a silent pass, a few spectra, a week of analysis. But what Mars witnessed that night was anything but routine. 29 million kilometers away from the red planet's surface, the comet's emerald glow deepened until it painted the thin atmosphere in green mist. Every probe, every rover, every orbiting eye suddenly began returning data no one could explain. Numbers spiked, sensors blinked, and a faint hum echoed through the static. In Houston, one engineer whispered, "Are we sure that's natural?" No one answered, because for the first time since humanity began watching the skies, something out there, something not from here, seemed to be watching back. And as the data continued streaming in, one unsettling truth became clear. Mars had just been touched by something the universe wasn't ready to explain. Months before that October night, a quiet tension had been building inside mission control rooms across the planet. NASA, ESA, and JAXA had all drawn up their own predictions, spreadsheets filled with simulations, probability charts, and models of coma expansion. The visitor, officially named 3I Atlas, was already rewriting textbooks before it even neared Mars. Its trajectory through the inner solar system had been described as mathematically improbable, its acceleration too steady, too perfect, as if guided by an unseen hand. Inside the Jet Propulsion Laboratory, monitors tracked every whisper of light the object reflected. In Pasadena, engineers sat through endless briefings. Expected flare within the 1% margin, no significant radiation hazard, record everything, even anomalies. Every word sounded precise, controlled, the vocabulary of scientists who believed the cosmos still obeyed the rules they knew. Out at Mars, 4 orbiters waited in alignment: MAVEN, Trace Gas Orbiter, Mars Reconnaissance Orbiter, and Mars Express. Together, they formed a net of silent watchers. Their sensors were primed for the moment the comet would cross the planet's orbital plane. A perfect opportunity to capture the chemistry of a traveler from another star system. On the dusty Martian surface, the Perseverance rover received secondary orders. Keep its environmental sensors awake through the night. Detect any shift in magnetic flux. Listen for micro-pressure changes. Curiosity, miles away, was told to do the same. Even InSight, long dormant, had a single remaining seismometer left on standby. Mars had never been this alert. For weeks, data streamed in, and everything matched the models. The object's brightness curve remained stable. Its coma was small, pale, consistent with carbon compounds. Scientists joked that the interstellar visitor was behaving better than most comets born in our own solar system. But beneath the humor was unease. The further 3I Atlas traveled, the more deliberate its path appeared. Minor gravitational nudges that should have distorted its trajectory were absent. Even Jupiter's massive pull failed to change its speed. When the European Space Agency released a statement calling the object's orbit elegant, the word drew laughter and quiet dread. By early October, all systems were ready. Commands were locked in, sensors calibrated, backup links established. The next 72 hours would be history's most detailed interplanetary observation of an interstellar body. No human had ever witnessed such a close encounter, and likely none would again for centuries. And so, on the eve of the flyby, as Earth rotated into darkness, dozens of mission control rooms dimmed their lights. Red dots blinked on wide screens. Engineers leaned in, silent, waiting. Somewhere beyond all their monitors, 3I Atlas glided into Mars's magnetic reach. No one knew it yet, but those first few seconds would unravel everything they thought they understood about comets, and about what drifts between the stars. At 4 o'clock Universal Time, Mars crossed into the shadowed half of its orbit, a rust-colored world wrapped in silence. Above it, in the thin chill of space, 3I Atlas approached from the outer dark. To telescopes on Earth, it was just a dim emerald spark. But to the probes orbiting the red planet, it was alive. The Mars Reconnaissance Orbiter was the first to lock on. Its cameras began recording continuous frames, one every second. The comet's coma shimmered faintly at first, a pale green haze against the black. Engineers monitoring from Pasadena described it as subdued, stable, ordinary. Those words lasted less than 10 minutes. As the comet neared the planet's orbital path, only 29 million kilometers away, the emerald hue deepened. Its tail, expected to trail behind it in a predictable arc, began to twist. The dust particles no longer obeyed the solar wind's flow. Instead, they coiled, looping like ribbons in an unseen current. At the same moment, Maven's magnetometers began registering spikes, soft, rhythmic pulses, repeating every 22 seconds. The same frequency would later haunt every data log that night. But in real time, no one noticed. Everyone's eyes were on the images streaming from orbit. On the Martian surface, Perseverance's Skycam captured the faintest green shimmer passing across the upper atmosphere. So faint, it looked like static until enhanced. Curiosity, on the other side of the planet, picked up a sudden change in radiation counts, then nothing. InSight's silent seismometer twitched once, as though responding to a passing breath. Inside NASA's Deep Space Network, the downlink feed from all Mars assets converged. Dozens of engineers stared at monitors filled with green haze, spikes of light, and numbers that didn't fit any model. The comet's luminosity began climbing, slowly at first, then exponentially. Instruments auto-adjusted, then overcorrected, then failed. "Recalibrate thermal gain," one controller shouted. "It's too bright," another replied. "Impossible. It shouldn't flare this fast." The object's coma swelled outward, expanding at 3 times the predicted rate. The color shifted from soft emerald to piercing jade, flooding sensors with radiation signatures they had never seen before. Carbon dioxide jets erupted from the nucleus, not in random bursts, but in symmetrical arcs, as if synchronized. For a few moments, Mars was bathed in green light, its surface, its dust storms, its thin clouds, all faintly illuminated by a stranger from another star. And then, just as suddenly, the brightness began to pulse. Not flicker, pulse. Slow, steady, 22 seconds apart. The same rhythm Maven had already recorded. In that instant, mission control rooms on 3 continents went silent. No one could say it out loud yet, but every scientist staring at the data shared the same thought. This isn't behaving like a comet. At all. What began as a flare became a storm. Within minutes, every instrument orbiting Mars was drowning in data. The Trace Gas Orbiter's spectrometer went into overload. Its sensors, built to read faint molecular signatures, suddenly flooded with radiation too bright to process. Automatic safeties kicked in. Systems shut down, rebooted, then shut down again. The numbers made no sense. The Mars Express confirmed it. Carbon dioxide, yes, but not just that. There were traces of cyanogen, a molecule so rare in deep space comets that its concentration was off the scale. In the control room, one chemist murmured, "It's like it's burning chemistry we've never seen before." At the same time, the Mars Reconnaissance Orbiter's infrared camera captured something stranger. Temperature fluctuations along the comet's surface that oscillated rhythmically in sync with the brightness pulses. One of the senior analysts leaned closer to the feed and whispered, "It's almost as if something inside is breathing." Inside JPL, tension thickened. Engineers compared timestamps from all orbiters. Maven, MRO, TGO, Mars Express. Every flare, every pulse, every data spike lined up perfectly. Across 4 independent spacecraft, separated by hundreds of kilometers, the same 22-second heartbeat echoed. NASA's Deep Space Network began prioritizing the feed, streaming the raw data to emergency review clusters. Servers struggled to keep up. In the telemetry logs, lines of green code flickered across screens faster than anyone could read. For a moment, the lights in mission control dimmed as power rerouted to the mainframe. Someone laughed nervously. Someone else whispered, "It's not supposed to talk back." And then came the light, not from the comet, from Mars itself. A faint luminescence spreading across the night side of the planet. It wasn't sunlight. It wasn't solar reflection. It was ultraviolet glow, an aurora in a place where auroras shouldn't exist. Solar flare? No, solar activity's quiet. Then what the hell is that? Monitors lit up with ghostly blue arcs over the Martian poles. The thin atmosphere trembled with radiation that didn't match any known pattern. The comet had passed by, but Mars was responding. Instruments recorded electric discharges, microbursts of charged particles rippling outward like a wave. And as quickly as it began, the flare collapsed. The light faded. The auroras died. But the instruments kept humming, still catching faint rhythmic pulses that refused to stop. It was the kind of event no simulation could predict, one that left even the most hardened astrophysicists staring at screens in disbelief. For a few long minutes, no one spoke. The hum persisted. The data kept climbing. And in that stillness, one realization cut through the confusion like a whisper across the void. Whatever just happened, Mars reacted. Hours after the light faded, Mars refused to return to silence. At 05:17 Universal Time, the Trace Gas Orbiter reported an anomaly, a sudden, unprecedented spike in methane within the upper atmosphere. The reading climbed fivefold in less than 6 minutes. Methane on Mars had always been a riddle, appearing in brief whispers, then disappearing without trace. But this time, it was sharp, structured, and perfectly timed with 3I Atlas's closest approach. In the telemetry logs, the methane curve formed an elegant arc, peaking exactly 22 seconds after each recorded light pulse from the comet. Engineers stared at the graphs, realizing the correlation wasn't coincidence. Someone finally said it aloud. "It's responding." Meanwhile, Maven's plasma detectors began to register violent oscillations. Streams of charged particles swept through Mars's magnetic tail, twisting the weak magnetosphere like fabric caught in a storm. On the night side, faint electrical discharges crawled through the thin upper air, blue ripples moving faster than any natural aurora. ESA scientists monitoring from Darmstadt cross-checked with solar data. There were no solar flares, no coronal mass ejections, no reason for the storm, and yet Mars glowed, a pulse of ultraviolet light rippling across its poles, faint but unmistakable. For the first time, the words "induced aurora" appeared in NASA's internal message threads. The working theory, the comet's plasma tail had brushed against the Martian atmosphere, transferring energy directly, a phenomenon only possible if the object carried its own magnetic field. But comets don't have magnetic fields, not like this, not strong enough to wake another planet. Back on Earth, the Deep Space Network scrambled to maintain contact. Minor static interference began creeping into all Mars channels, a low rhythmic hum buried beneath every transmission. NASA's public feed remained calm, but behind the scenes, engineers fought to isolate the source. It wasn't solar interference. It wasn't hardware. It was coming from Mars itself. The methane readings plateaued after 40 minutes. Then, as abruptly as they began, they stopped, falling to zero in seconds, as if switched off. The atmosphere returned to its usual thin silence. But the data lingered, mocking explanation. Somewhere in the noise, a pattern remained. Faint, insistent, impossible to ignore. Every probe, every orbiter, every antenna still picked it up. A steady rhythm. 22 seconds apart. A heartbeat echoing across the void. Inside Mission Control, one scientist broke the silence. "If this were Earth," she said softly, "we'd call that a signal." And for the first time in the entire operation, no one argued. At first, the hum was dismissed. Mission Control labeled it telemetry contamination, a glitch in overlapping data streams from Mars orbit. It wasn't the first time a signal repeated in the background. But as the night deepened, more reports came in. Maven's plasma spectrometers, Mars Express's magnetometers, even Perseverance's low-frequency microphones. All of them were recording the same rhythmic pulse, 22 seconds apart, always 22. Inside the Jet Propulsion Laboratory, dozens of engineers gathered in the dim glow of monitors. On one wall, an audio spectrum scrolled in real time, a faint, repeating heartbeat of static. It wasn't strong enough to be communication, not chaotic enough to be random. A perfectly steady pulse. Telemetry issue? Not possible. We're on separate frequencies. Solar interference? Solar winds quiet, dead quiet. The chatter faded as someone played the signal through the room's speakers. It was low, a murmur, almost below hearing, but it moved, like a slow, distant vibration, the kind you feel before thunder reaches your chest. For 22 seconds, it was silent. Then again, the same pulse. NASA's Deep Space Network triangulated it. The source wasn't the comet. It wasn't Earth. It came directly from Mars's upper atmosphere. The command room went still. Someone whispered, "It's reflecting?" But the pattern wasn't reflection. It was coherent, consistent across all detectors, with a phase lag of milliseconds. That meant timing. That meant intention. At a 6:12 UT, ESA's Mars Express confirmed the same rhythm from its position on the far side of the planet. 2 spacecraft, 2 separate systems, 1 identical signal. NASA called an emergency cross-agency briefing. Across screens, faces appeared from Pasadena, Houston, and Darmstadt. The lead systems engineer summarized, "We have a harmonic emission synchronized between orbiters, repeats every 22 seconds, power level negligible, coherence near perfect." A pause. Then a single question from the director of planetary science, "Is it artificial?" Silence. The team lead hesitated. "Statistically, no. But physically, we can't rule it out." Behind the technical talk, fear crept in. The last time NASA had heard rhythmic signals from space was during solar flare testing in the 70s, and those were easily explained. This wasn't. One analyst, a veteran of the Voyager missions, wrote in his log, "If it's a message, it's not aimed at us. It's aimed through us." Hours later, the official line was ready. The pulse is a naturally occurring plasma resonance between the comet's charged tail and the Martian crust. It was the safest explanation possible. The public would never know how unconvincing it sounded when spoken aloud. But off the record, in private chats and encrypted emails, scientists traded a different term. Coordinated. Yon harmonic signature. The pattern was too perfect, the duration too precise. Some claimed to see micro-variations encoded within the pulses, faint shifts as though the hum itself carried information. When the shift occurred at 6:44 UT, it was barely noticeable. The pulse shortened by half a second, just once, then resumed its rhythm. Yet every spectrometer picked it up. Every orbiting sensor confirmed it. That night, one engineer refused to leave the control room. He stared at the screen until sunrise, listening to the signal repeat over and over, steady as a heartbeat. And when it finally stopped, exactly 94 minutes later, he swore he could still feel it, faintly in his chest. A pulse from the red planet. A rhythm not born of wind or plasma, but of something waiting. By dawn in California, the hum had stopped. But the questions had just begun. Inside NASA's Jet Propulsion Laboratory, the conference room felt heavy. Screens filled with graphs and spectrograms, looping the same faint pulse. Around the table, engineers and astrophysicists argued in low voices, their faces pale in the light of the monitors. The first theory came from the plasma physicists. They insisted that what Mars had experienced was a natural resonance event, a reaction between the comet's ionized tail and the planet's weak magnetic crust. "Think of it as thunder," one said, pointing to the waveform, a vibration born from contact. But others disagreed. "If it's thunder," replied Dr. Hannah Lynn, the spectroscopy lead, "why is it timed?" She highlighted the 22-second intervals. "Natural systems decay. They don't count." The room fell silent for a moment. At ESA's control center in Darmstadt, European scientists proposed another explanation, a plasma standing wave bouncing between the comet and Mars's ionosphere. Possible, yes. But when they modeled it, the resonance decayed after 3 cycles. The real signal lasted over 200. In Houston, a separate NASA team analyzed the methane surge. Their findings only deepened the mystery. The spike had begun exactly 22 seconds after the comet's light flare and ended the moment the pulse ceased. "That's correlation to the second," one chemist whispered. "It's not coincidence, it's choreography." As the hours passed, unofficial theories began to leak. A quiet message thread titled "Guided Fragmentation" appeared on NASA's internal network. Some of the orbiters had captured shards breaking from the comet's nucleus. But instead of scattering randomly, they spiraled. Engineers called it coordinated drift. The term didn't last long before being redacted. The boldest theory came not from a scientist, but a programmer. He noticed faint variations within the 22-second pulses, microscopic shifts in frequency, almost imperceptible, but regular. He proposed an outrageous idea. What if the pulse wasn't a sound, but a carrier? When he presented it during the late-night debrief, the room erupted. "It's noise! It's compression artifacts! Do you hear yourself? A comet sending data?" But he stood by it. "Look at the pattern," he said quietly. "It's not random, it's structured. The harmonics climb and fall in sequence, almost like what?" someone demanded. He hesitated, like a handshake signal. For a moment, no one spoke. The words hung in the air, forbidden, impossible, electrifying. The next morning, NASA released its public statement. The signal observed during 3I Atlas's flyby of Mars was determined to be a plasma-resonant phenomenon consistent with cometary interaction. No evidence of artificial origin was found. Behind closed doors, the tone was different. Private memos warned against speculation. Raw data was encrypted and restricted. Scientists who spoke to the press were reminded of their confidentiality clauses. But inside the labs, the whispers grew louder. If the object had no magnetic field, how did it induce auroras? If it was inert rock and ice, how did it modulate a 22-second rhythm? If it was debris, why did it react to Mars? And the quiet question no one wanted to put in writing. What if 3I Atlas wasn't reacting at all, but communicating? By the next sunrise on Earth, the story had already escaped NASA's walls. At first it was a whisper, a few screenshots shared between amateur astronomers on Reddit and Discord. Then, by noon, it was a wildfire. The words, "Emerald Comet over Mars," were trending across the globe. Someone in Chile posted a long-exposure image of the planet, faintly tinted green. Someone in Japan uploaded a spectral graph showing a surge in diatomic carbon emission. And before long, every observatory with a view of the red planet was pointed toward the same luminous visitor. NASA remained silent for 6 hours. ESA followed suit, calling the data under review. The only official update came from a single line in the European Space Agency's bulletin. Unexpected atmospheric response detected on Mars, source unknown. But silence only fueled curiosity. Within 24 hours, observatories from Chile to Hawaii reported that 3I Atlas had doubled in brightness. Its coma had expanded far beyond prediction, shining brighter than any comet within that orbital zone should. To many, it looked as though the object had absorbed something during the encounter, as if Mars had ignited it. Across the internet, theories multiplied. Some claimed the methane surge proved that 3I Atlas had delivered organic molecules to Mars, an interstellar seed. Others insisted the pulses were evidence of a self-regulating magnetic field, a property unheard of in natural comets. The most extreme voices whispered about engineering, about geometry hidden in the debris pattern, about the hum being a kind of activation sequence. In Arizona, the Lowell Observatory began organizing public live streams of the comet's next phase. Thousands joined, their screens filled with the soft emerald shimmer moving steadily toward the inner system. In California, students gathered outside with telescopes, straining to glimpse a green star that shouldn't be there. In homes around the world, people who had never cared about astronomy before suddenly looked up. Meanwhile, far above Earth, the James Webb Space Telescope prepared its instruments. For days it had been waiting on the far side of solar conjunction, its massive mirrors cooling in the dark. When 3I Atlas cleared the sun's glare, Webb turned its gaze toward the object. Spectrometers aligned, detectors armed. But even Webb wasn't ready for what it saw. Preliminary data, later leaked to the press, showed irregular spikes in infrared reflectivity, periodic brightening at precise intervals of 22 seconds. The same rhythm that had haunted Mars was now echoing across deep space. An ESA scientist, speaking off record, said quietly, "It's as if something inside is still running, still alive." Governments convened briefings. The Pentagon demanded access to NASA's data stream. The European Parliament called for an independent review. Yet, despite the noise, there was one strange, unifying silence. No one dared to call it artificial, not yet. For all the data, for all the theories, one simple fact was inescapable. Every time humanity looked closer, 3I Atlas looked back, and now it was heading inward, toward the sun, toward Earth's orbital path, carrying with it the same impossible heartbeat that had left Mars forever changed. For days after 3I Atlas slipped behind the sun, the world waited for word. Every observatory turned its dishes skyward. Every data feed ran through silence. NASA's nightly briefings grew shorter, emptier. Still no signal. Still analyzing telemetry. It felt as though the universe itself had inhaled and refused to exhale. Then, on the morning of November 3rd, a whisper returned, not from the comet's location, but from Mars. The Trace Gas Orbiter picked up a residual oscillation, faint, rhythmic, fading with each rotation of the planet. The same 22-second pulse, now softer, like an echo trapped in stone. Scientists called it residual magnetospheric coupling, but among those who had watched the data from the beginning, it felt like something else, like a memory, as though Mars still remembered being touched, and perhaps, in its thin air and silent plains, it still hummed the melody of that passing visitor. Down on Earth, we argued about everything. Was 3I Atlas alive? Was it a machine? Was it a messenger? Or merely a mirror showing us our own hunger to believe? The debate stretched from universities to online forums, from newsrooms to late-night radio. Some found hope in the idea that we were not alone. Others found dread, because if it truly was intelligent, then it was far beyond us. But maybe the truth was quieter than both. Perhaps 3I Atlas wasn't trying to speak at all. Perhaps it was simply moving, following the same ancient rules that guide everything in the dark: gravity, chemistry, light. And it was we, fragile creatures of pattern and meaning, who mistook its rhythm for a heartbeat. Or perhaps not. Because when the James Webb Telescope finally caught its next glimpse, weeks later, it recorded something that shouldn't have been there: a series of faint luminous nodes drifting in formation behind the sun. Not random, not natural, aligned, waiting. NASA released no statement. The data was classified. But one analyst, before the report was sealed, wrote a single line in the margin of his notes. Sometimes the universe knocks softly, rhythmically, just to see if we're listening. And that is the question that still echoes tonight. Did we simply witness a comet brushing past a dead world? Or did we watch the first act of something older, something deliberate, unfolding across the inner system? When historians look back on October 3rd, 2025, they may not remember it as a comet flyby. They may remember it as the night Mars was marked. And humanity realized that interstellar visitors do not always come quietly. Because somewhere out there, beyond the heat of the sun and the static of our instruments, something is still humming. Not loud enough to terrify, just loud enough to remind us that the sky is listening too.